Hi guys, this is Andrew.
And this is Jules. Welcome back to Code School.
Today we're going to talk about this week's game, which is based on the Atari game Breakout. But before we do that, we need to learn how Pygame handles images.
Up till now, Pygame has seemed difficult to be honest. The surfaces and recs concept hasn't always been intuitive. Making simple controls like buttons and input fields is much more complicated than with other GUIs. So you may be wondering why we're even using Pygame. Now we're going to really start seeing where Pygame shines, and it starts with the sprite.
Pygame has a special class called Sprite. This is used to instantiate any graphical object you want to be interactive or animated in any way. This could be for a button you want to be clickable, it could be your player's avatar you want to move around, or it could be a bunch of blocks you want to be able to collide with a ball. It can be drawings like we've used already, or even better, it can be images. Now we can start making our games look much more interesting. We can customize literally every single element we use now.
And the best part is that it is actually really easy to do. To begin, let's start with loading an image. We do this by using pygame.image.load and passing it the name of the file. This creates a surface. We can then just split this surface onto our main surface to see the image. Split has an optional argument called area that is a rect that specifies the location and size of the surface we want to draw. We can use this optional parameter to crop our image. If we leave this argument off, it will draw the entire image.
Now if we want to really benefit from using Pygame and we want our images to be interactive and or animated, we can simply make them sprites and put them in a sprite group. To do this, we create a sprite group with pygame sprite.group. Then, in order to make the image a sprite object, we can create a class that inherits from Pygame's sprite class. By inheriting from Pygame's sprite class, we gain access to methods that are already there, such as many types of collision detection, the ability to add and remove it from sprite groups, and the ability to detect if it is in any group.
We have to make sure a few things are present in our new sprite class though. First, we must have an update method. The one in the parent class is just a hook. This is the method that will get called when we do an update on any group that this sprite is a member of. So for example, if we make a block class and we put any blocks we make into a sprite group called blocks, when we call blocks.update, each block that is in the group blocks will be called with the block class update method. In addition to update, we also have to make sure to assign the following attributes: self-image, self-rect, and self-radius if we're planning to use the circle collision detection features.
Maybe the best way to see how to use the sprite class is to check out our breakout game. You'll notice when you go to our GitHub page and click on the breakout folder in the code section that there are many files in addition to the resources and utilities 1 folders. Many of the classes have been put into separate files. This is a beneficial approach when it comes to testing the code. Each file contains one class. It also contains a main function that tests the class in isolation. Being able to test each class on its own helps us narrow down bugs during development. Putting each class in its own file also makes the code cleaner. Finally, it makes it easier to understand which classes use which imported modules, since we only need to import the modules used in each file.
BaseSprite.py is the sprite class we have created. You can see that it has the required update method, as well as the attributes for self-image and self-rect. You may also have noticed that it has 3 properties, labeled X, Y, and position. Also, there is another file called point that has a point class that only has 2 properties, X and Y. To create a property, we first have to declare get and set methods, and then we just use the property call to establish this feature. Now we can access these properties or change them by simply referencing them as attributes. For example, if we make a base sprite called ball, we can change the x property by 2 with ball.x plus equals 2. This is a good time-saving way to code class attributes you often need to access or alter, like positions of objects. The last method I haven't covered yet is the setImage method. This method is used to set an image for the sprite, but it also sets the self.rect attribute and an attribute called self.columns. These are used for sprite sheets where the image associated with the sprite isn't necessarily just one static image. In Breakout, we have a sprite sheet that includes all the different colors of blocks that are used. Each block is an instance of the base sprite class, but they aren't necessarily the same color. This setImage method allows us to specify that the width and height of one block is not the same as the width and height of the entire image we are passing. The columns number tells the method how many blocks are in a row. If we don't supply the width, height, or columns, the default is that the image is just used in its entirety.
The next new class we have created is the image loader. This class handles loading images. It starts with a try except clause that exits the game if the necessary files aren't located or if they cannot be loaded. Then it has three other methods. We are only using load in Breakout. It is used to load a subimage of a larger image. We use this to pull images off our sprite sheet. The advantage of the image loader class is that the sprite sheet is actually only loaded once at instantiation. We also use the load method to load an image that is the same size as the original image, like we did with our background images. The level loader works a bit differently. It takes a text file with all of the level information and opens it if available. If it isn't, it defaults to using a demo level. That way, the game will still play one level and a message will print warning the user that the levels file is missing and is operating in demo mode. If the levels file is found, however, there is an extract levels method that pulls the information off the text file and returns it to a usable format.
The UI and PG extra files have been updated too. UI now has a getSound method that gets a sound. All you have to do is pass it the file name of the OGG file. It will return the Pygame sound, which can be stored as a variable that can then be played with the play method. PG extra has been made into a package instead of an individual module. Splitting PG extra into a package helps to keep it readable and manageable. Notice that each file contains a single class along with the main function for testing that class in isolation. The package file init then imports all of the modules in the package. We can then import the package and it will appear externally to be a single module.
As I said earlier, note that the breakout states are also each in their own modules. Again, this allows each class to be tested in isolation. But notice there is no package. We could use a package here for all the states. In future games, we may. However, creating a breakout package wouldn't add any real benefit.
Now that we can draw images, PG Extra got another widget added to it. This is a special button that takes an image or series of images and uses that instead of drawing a rectangular shape. The button has 4 different states which can each take a separate image. So now when the player hovers over the button or presses the mouse button, they can see the effect. There is also a disabled state that can be used if the button isn't active. These states were also added to the regular PG Extra button using a border and altering the default colors.
We've seen enough code for now. Let's take a look at the actual game. It starts with a title splash screen that cycles to a start screen and then later to a high scores page. We use the same start state as in our previous games like Wacadot and React. The actual start button is a PG Extra special button. Clicking the start button transitions the game to the playing state.
In the previous states, everything except the start button was just a static image. Now all our graphical elements are sprites because we want them to interact. One thing we did forget to do was put in some basic instructions. To start the ball moving, the player hits the spacebar, and to move the paddle, they use the left and right arrow keys. Another thing we need to do is make the mouse pointer invisible in the playing state, or implement mouse controls for the paddle. But back to the game. The spacebar starts the ball, which can now interact with the blocks, the walls, and the paddle.
Hey Jules, where are the amazing sound effects we added?
Oh, that. Yeah, I muted the game for the video demonstration.
But the sound effects totally make the game.
You're right, but for the video, it's kind of distracting to have that much awesome to compete with while I'm trying to talk about the game. I figured we'd let that be a surprise for the people who actually go to the trouble of downloading it.
Fine, but I did work really hard on those, and they totally make the game.
Yes, they do. But back to the game. When the player clears all the blocks for the level, the next level appears. Then it continues until there are no more levels or the player has lost all 3 of their lives. At this point, the game transitions to the game over state, which is again almost a copy-paste of the previous game over states used.
Yeah, I would like to mention how amazing game states are. Because they allow us to separate the game into pieces, and since many games use the same kinds of pieces, we are able to use those pieces like building blocks to create more and more games with very little work.
We could even take this a step further and create states with completely generic parameters for things like the background or controls. Then these states would be even more versatile.
So Jules, what's the optional assignment this week?
I think a great assignment would be to further enhance Breakout. There is so much room to create more features and improvements here. First of all, it does need some kind of instructions to the player. There could also be some kind of level transition. I also think the game needs a soundtrack with music for the intro and the various levels. Also, it would be much more interesting if the levels actually increased in difficulty. Perhaps the ball could get faster, or the paddle could get smaller, or additional sprites could be added that create havoc of one type or another.
The possibilities are endless. I better go work on more sound effects. Thanks for watching, guys, and we hope you enjoy playing around with Breakout.